Hello students, how are you all? Welcome to our YouTube channel Step Up Classes. Our today topic is trigonometry from standard 10th. Here we will discuss about the introduction, trigonometry ratio, the basic concepts, and we will learn about the basic questions based on basic concepts. So let us start. Trigonometry actually is a branch of mathematics in which we learn about the relationship between the sides and angles of a right angle triangle. As trigonometry words is formed with two Greek words, trigonon plus metron. Trigonon means triangle and metron means measurement. That means we will learn about the relationship between the sides and angles of a right angle triangle. So let's go to next topic, that is trigonometry ratio. Before understanding trigonometry ratio, I would like to recall right angle triangle, which you have learned in previous classes in standard 8 as well as in standard 9th. So you have learned in right angle triangle that there were three sides. One of them is called hypotenuse, second one is perpendicular, and third one is base. So here I would like to change a little thing, because we are talking about angles and sides. So therefore if we talk about one angle, so make sure its opposite sides will be perpendicular sides, its adjacent sides will be base, and remember the opposite sides of right angle is always hypotenuse sides. I hope you got it. For example, as you can see in this figure, that there is angle theta, this one. So opposite sides of this angle will be perpendicular side. The adjacent sides of this angle will be base, and the side opposite to right angle will be hypotenuse. I hope you got it. So next what we have, trigonometry ratios. Also I have initially represented side AB of this triangle AB by A, BC by B, and CA by C, where in which triangle ABC, in which angle ABC is equal to 90 degree. So let us discuss about the T ratio now. What is T ratio? T ratio stands for trigonometry ratio. Trigonometry ratio are nothing but the ratio between the sides of a right triangle. These ratios are given by the following trigonometry functions of the known angle theta, as you can see in figure, where ABC refer to the lengths of sides of right triangle ABC, as I have mentioned in the above figure. Okay, so let us talk about sine theta. Theta is actually angle and sine is trigonometry ratio. So make sure that trigonometry work in right angle triangle only, and there is an for particular angle, it may be theta, it may be pi, it may be alpha, it may be beta, or you can represent it by the coordinate vertices of triangle ABC as well as. So sine theta is a ratio of opposite sides to the hypotenuse, which can be written as refer to the figure triangle ABC, AB by AC, and in the terms of their length it can be written as A by C. Similarly, cos theta is the ratio of adjacent sides to the hypotenuse sides, which can be written as BC by AC. In the terms of their length it can be written as B by C. And similarly, tan theta can be written as opposite sides ratio to the adjacent sides, which can be written as A by B. Now similarly, cot theta is equal to adjacent sides to the opposite sides, which is equal to B by BC by AB, that is equal to B by A. Sec theta is actually equal to hypotenuse sides to the adjacent sides, that is equal to C by B, or we may write AC upon BC. Similarly, cosec theta is equal to hypotenuse sides upon opposite sides, which can be written as AC by AB, and that is equal to C by A. Let me tell you one thing. As you can see that sin theta is equal to opposite sides divided by hypotenuse, and cosec theta is equal to hypotenuse upon opposite sides. So we may say that sin theta and cosec theta are the reciprocal of each other. In the same way, you can see that cosec theta is equal to adjacent sides upon hypotenuse, while sec theta, cosec theta is equal to adjacent sides upon hypotenuse, and sec theta is equal to hypotenuse upon adjacent sides. That can be written as C by B, and cos theta can be written as B by C. So we can say cos theta and sec theta are reciprocal to each other, and in the same way we can say tan theta and cot theta are also reciprocal to each other. This is called the reciprocal relation between trigonometry ratio. I hope you got it. Let us move to next. That is actually the same things I have recently explained, the reciprocal relation between the T ratio. As I told you from the figure, adjoint figure, sin A, make sure here I am using A instead of theta. So for this angle A, let me tell you, for this angle A, its opposite sides, these sides BC, angle A, opposite sides BC will be perpendicular, AB will be base, and the opposite sides of right angle will be hypotenuse. Let me write, this is hypotenuse, this is base, and this is perpendicular. I hope you got it. So now you can see that sin A, as I told you, sin A is a ratio of opposite sides to the hypotenuse. So opposite sides, here we have BC, as you can see, and hypotenuse we have AC. So we can say sin A is equal to BC upon AC. Similarly, cos A, for we are talking about the angle A, therefore cos A is the ratio of base to the hypotenuse. So base we have AB and hypotenuse we have AC. So we got cos A is equal to AB by AC. Now let us talk about the tan A. So tan A was the ratio to the opposite sides to the base. So now you can see opposite sides is BC and base is AB. So it is the ratio of BC to the AB. You got it? Now cot A, as I told you that cot A is the reciprocal of tan A. So you can write, you can see that tan A is equal to BC upon AB. So cot A should be equal to AB upon BC. Similarly, sec A is the reciprocal of cos A. So you can say cos A is equal to AB upon AC here. So sec A should be equal to AC upon AB here, because this and this, cos A and sec A are the reciprocal of each other. Similarly, now you can see that the sin A, let me show you, sin A is BC upon AC. You can see, so cosec A should be reciprocal, that means it should be AC upon BC. By these terms we can conclude one thing, that sin A is equal to 1 upon cosec A, cos A is equal to 1 upon sec A, tan A is equal to 1 upon cot A, cot A is equal to 1 upon tan A, and sec A is equal to 1 upon cosec A, and cosec A is equal to 1 upon sin A. That means simply you can learn that sin is the reciprocal of cosec, as well as cosec is the reciprocal of sin. Therefore cos A is the reciprocal of sec A, and sec A is the reciprocal of cos A. Now again tan A is the reciprocal of cot A and cot A is the reciprocal of tan A. I hope you got it all. Okay. Now the relation between sine, cos and tan. If we try to find the ratio of sine A as well as cos A by their respective sides, so as you can see, sine A was BC upon AC. You can see from here, sine A is equal to BC upon AC and cos A is equal to AB upon AC. So if we divide them, so you can say AC should be cancelled out. So what should be there? It should be BC upon AB, which can be seen at last. You can see that BC upon AB. So we can say that tan A is equal to sin A upon cos A, and since cot A is the reciprocal of tan A, as I told that cot is the reciprocal of tan A, so we can say that cot A should be cos A upon sin A. So this is the relation between sin, cos and tan.